All right, welcome to Unit 5. So this week we're starting Part 3, Network Attacks and Defenses. In that unit we're going to be covering networking and server attacks, network security, devices, design and technology, administering a secure network, and wireless network security. So let's dig in, and don't forget you still need to finish Assessment 1. That'll open up at 6 p.m. Today. So make sure you complete Assessment 1, and Assessment 1 covers all chapters up until this week. So Unit 5 is going to have a lab simulation, a live virtual machine lab, study material, and a quiz. So ensure that those are completed by Wednesday of next week. All right, let's dig in. Okay, so the objectives here, we're going to be describing network attacks. We're going to cover things like man-in-the-middle, ARP, DNS, and replay attacks. We're also going to be going over server attacks, including denial of service, web app attacks, hijacking, overflow attacks, advertising attacks, and attacking browser vulnerabilities. Right, so network-based attacks. So there are several attacks that target a network or a process that relies on a network. So these are broken into two buckets for the purposes of this test, or of the Security Plus certification, and they call them interception attacks and poisoning attacks. So interception attacks are they're designed to intercept network communications. Right, and this the most common types are the man-in-the-middle, man-in-the-browser, and replay attacks. So here's a little diagram of man-in-the-middle attack. You've got two endpoints of a communication and a man in the middle, or an attacker in the middle. And so this attacker has devised a way to intercept communications intending to go in between these two hosts, usually by spoofing either DNS or ARP. Right, so just to make it a little more clear, so Bob and Alice are trying to communicate. He sends a message, it says, "Send me your public key." Alice replies with her public key, but it's intercepted by the attacker, and instead a different public key is forwarded on to Bob. Then Bob replies with a sensitive message. It's also intercepted by the attacker, altered, and sent on to Alice. So man-in-the-browser is a little bit different. So man-in-the-browser attacks intercepts communications between parties to steal or manipulate data. So it usually begins with a Trojan infecting the computer and installing an extension into the browser configuration. Right, and so it's going to be manipulating form information. When a user hits submit, it can capture all the data going into the form and send it to the attacker. There's a recent example of this called MageCart. It's affecting some of the e-commerce sites currently. I think just last week, Newegg.com, if you're familiar with that, you buy computer parts from there, has been affected by MageCart. There was a British Airlines, I think Delta was. It's in the thousands of sites that are affected by this MageCart, which is a man-in-the-browser attack. Right, and that's distributed through a Trojan browser extension, and we'll cover that a little bit later on in the slides. Right, and since it is within the browser, that it's a different type of malware. It's not an executable that's running independently as its own process. It's taking advantage of the browser's running process and interacting with the browser to do malicious it's malice. So it's a little bit more difficult for anti-malware software to detect. It's also rather difficult to investigate as well from an incident response perspective. So replay attacks are when the attacker is able to view the communications in some way, is able to copy it, and then replay that web traffic. So the example they give is, maybe a user is logging into an FTP server. The attacker is able to capture that network traffic. He's somehow on the network in a position where he can see that traffic going by, and is able to capture that and simply replay the traffic to gain access to the FTP server, or, that's just an example. Right, and to prevent the replay attack, you need to negotiate and create a random key that's valid for the limited period for a specific process. And so that's known as a session token. Right, so poisoning in general is the act of introducing, and they call it a substance that harms or destroys, but it's introducing something that causes damage. And so they've divided this into 3 types here: ARP poisoning, DNS poisoning, and privilege escalation. Now, that threw me off a little bit. I normally consider privilege escalation a poisoning attack, but that's where they have it in the content, so that's where we're going to discuss it. So address resolution protocol. So in order to understand ARP poisoning, you kind of first need to understand ARP. So kind of simplified explanation of what address resolution protocol is so 2 computers on the same LAN, let's say computer A has an IP address of 192.168.1.1, and computer B is at 192.168.1.2. Right, so those are on the same subnet. Let's just say that subnet mask is 255.255.255.0. If that were to be written out in CIDR notation, it would be 192.168.1.0 over 24. That's just a little bit of networking. So it's basically saying the same subnet where the last IP address is the variable. So what ARP does is it allows systems to communicate with each other on layer 2, the physical layer, over Ethernet. So let's say computer A wants to send a message to computer B. Computer A knows the IP address of computer B, but not the MAC address, which is required to send the Ethernet packet on the same subnet. So to find the MAC address, computer A sends an ARP request to the subnet's broadcast address. So the broadcast address is usually the last IP address in the subnet. In this case, that's 192.168.1.255. And so the purpose of a broadcast address is you can send a message that is broadcast to all IP addresses on the network, on that subnet. So computer A sends an ARP request to the broadcast address, so all computers see it. And the ARP request says who has 192.168.1.2 tell 192.168.1.1. Right, and so whichever computer on the network that has that IP address will respond. So computer B has that IP address, it hears the broadcast message, and it responds with an answer message saying, hey, this is my MAC address, I'm at 192.168.1.2, you can forward your communication onto me. So that allows computer A to send the message over Ethernet to computer B. So that's ARP in a nutshell. So then ARP's poisoning then would be, it relies on spoofing. So when that broadcast message goes out and all computers on that subnet hear that message, the attacker, given that they're on that same physical Ethernet connected network, sees the ARP address and replies and says, hey, that's me, even though it's not him. It says, that's me, and here's my MAC address. Right, so the purpose there, there can be a lot of purposes. So they give the examples of stealing data, preventing internet access, man in the middle of attack. That's kind of the most common when you think of ARP poisoning, is the man in the middle of attack. And you've got denial of service attacks as well. So DNS poisoning is similar in concept, but how it plays out is a little different. So again, in order to understand DNS poisoning, you first need to understand DNS. We don't, go into too much networking in this class. Hopefully you have some experience, but if not, here's so DNS in a nutshell, or DNS simplified. Well, let's start with a little history. So in the beginning, we had the ARPANET. We're talking back in the 60s and 70s. So the network was used by military research institutions, as well as the military. When it first started out, there were just a very few number of systems, and the users of those systems could remember each other's IP addresses, and they would use those addresses to talk to one another. But as more systems came online, that quickly got out of hand. So they came up with a way to map an IP address to a human-readable name. And they used what we call a host file, which is still in use today. So host file is what you see here. Here's an example host file. It says, so 127.0.0.1 is always yourself. It's a loopback address or local host. But in this case, say you wanted to talk to Western Kentucky University, you would enter that domain name, www.wku.edu, into the host file, mapping it to the IP address that serves up that web page, or that whatever's listening there. It doesn't have to be a web page. And so the computer keeps track of which domain is at which IP address, or which host name is at which IP address. So you don't have to remember that on your own. And that worked right until you got lots and lots of systems on the network now. And so maintaining everybody's host files was getting out of hand. So they came up with a way to manage that host file centrally, and then people would just go and pull the latest host files so they had the most updated information. And that has kind of evolved into what we call DNS today, domain name system. Right, so DNS servers serve to inform systems of other IP addresses. So that allows for wide area networking, or WAN networking. So instead of having to know ahead of time, the IP address of Google, you can type www.google.com into a browser. Then your system will say, okay, I'm not familiar with google.com. What's my DNS server? Let me go ask that DNS server what google.com's IP address is, and that's how you would get the answer and be able to visit google.com. Right, so the DNS server replies with an A record with that IP address. So let's kind of take a look at how that works. All right, so NSLOOKUP is a tool on Windows, Unix, Mac. So it's basically uses DNS. So if I want to look up www.century.edu, we've got an IP address of 23.21.222.45, right, which is hosted in Amazon AWS. So it's got two servers that host up that content. So then DNS poisoning is, again, when you poison, you add something, in there to cause to cause harm. So the attacker will look up, so in this instance, the attacker is looking up the address of www.evil.net. The attacker is in control of evil.net in this situation. So the DNS server will, it says, I'm not familiar with evil.net, so it will ask the authoritative DNS server, which is under the attacker's control, or ns.evil.net. So ns.evil.net will reply back with not only www.evil.net, but www.good.net, .better.net, .best.net, so things that weren't requested. And then it says that's all, it's all the attacker's IP address. Right, so that would be an example of poisoning. So now you have these records in the valid DNS server that point to the attacker's computer. And then when the good user comes around and says, I want to visit www.good.net, it gets an IP address that does not belong to good.net. It belongs to the attacker's computer. All right, so privilege escalation. Again, I'm not clear why they stuffed it into poisoning, but that's where it is, right? So we'll talk about it here. But privilege escalation is basically access rights. So when an attacker gets access to a system, typically they're running as the user that either executed their malware, or maybe they exploited a vulnerability of a service, and so they're running with the privileges that service is running under the context of. So typically, when you get onto a system as an attacker, you don't have the privilege that you need to really get at what you're after. So typically the first thing you're going to do is try to get administrative access on the system that you are on. So on Windows, that could be a user in the administrators group, or eventually you want system level access, or the system account. On a Linux system, root is the account that they're trying to escalate to, right? And that's called vertical privilege escalation. So horizontal privilege escalation would be an attempt to access data that maybe the user that you're running as, that you're operating as, doesn't have access. So maybe you've compromised a user in accounting, but you really want to access data on a marketing server. So horizontal privilege escalation would be getting access to data that is controlled by other unprivileged users, just not the one you're on. So you've got to move around to try to get the right accounts to access the right privilege, or the right data that you're after. So that's horizontal privilege escalation. Right. So moving on to server attacks. So those were poisoning attacks. Here we'll discuss server attacks. We'll talk about denial of service, web server application attacks, hijacking, overflow attacks, advertising attacks, and exploiting browser vulnerabilities. So denial of service. So when we talk about a denial of service, we're talking about an attack whose goal is to prevent a system from functioning properly. If it serves up, an FTP site, a denial of service of that would be to prevent its users from accessing that FTP site. So most DOS attacks today, DOS, denial of service, are all interchangeable, are distributed denial of service, or DDoS attacks. And so DDoS attacks utilize a multiple hosts to conduct the attack. So in a lot of cases, this will be if an attacker has an existing botnet with thousands or tens of thousands of computers on it. They can say, hey, all of issue a command to the bots to conduct attack traffic on the target server they want to take down. One of the examples that they give here is the Smurf attack. And so Smurf attack is, I guess this is more of a history lesson. It's not something you're going to see in any production environment. This is, it's not 1999 anymore. But just to explain it, the Smurf attack, it's also good for security trivia, right? Everyone should know what a Smurf attack is. If you send an ICMP echo request or a ping, if you're not familiar, so ICMP is a protocol on top of IP. ICMP is Internet Control Message Protocol, and that's used for ping, packet internet network groping. Right, so the Smurf attack is, so when you ping a system, you're basically saying, hey, are you there? And it'll respond with a reply that says, yes, I'm up. Right, so if you send an echo request or a ping to a large subnet, let's say, as an example, Amazon's AWS East Coast location, one of their ranges is 50.19.0.0/16, which is CIDR notation for Class B network, with a possible 65,000 IP addresses. Right, so all of those IP addresses are the ones that are actually online using an IP address that are configured to reply to pings. The idea there in a Smurf attack is that they will all reply with an ICMP echo response packet. So if you were to ping a large subnet from your computer and they all respond, that's, your computer is probably not going to be able to handle the response from 65,000 computers all at once. Now, if you change or spoof that IP address that the ICMP echo request originates from, then the IP address that you spoofed will receive all of those 65,000 echo responses. So the Smurf attack there is spoofing your attacker's IP address in the echo reply, and then having a massive amount of systems reply to that echo request. Right, so that's a history lesson, because in about 1999, router configuration standards changed such that routers now are configured to drop packets that are sent to broadcast addresses, meaning to have a successful Smurf attack, you really need to be operating on the same side of a router. You can't be traversing a router as both your victim and the hosts that you want to use to conduct the DDoS attack. Right, so this would need to take place in a very large internal network. So effectively, the Smurf attack is no longer a valid method of denial of service. DNS amplification attacks, on the other hand, are able to be used by actual attackers, and I've responded to a DNS amplification attack before. And what your book describes as an amplification attack is they're actually describing a reflection attack, but it's not to nitpick. But so an amplification attack. So an example would be so that it takes advantage of misconfigured or vulnerable DNS servers. So a vulnerable DNS server can receive a malformed DNS request, malformed in the way that it contains a lot more data than a typical DNS request should receive. It will not drop that. It'll process the very large DNS request and send it back to a spoofed IP address. Right, so the attacker spoofs, just like in the Smurf attack, it spoofs the originating IP address so that the reply goes to the target system. Right, and so if you do that in rapid succession with very large DNS originating from multiple hosts, you can utilize a vulnerable DNS server to conduct. And typically you want to use multiple DNS servers, but you can conduct a very effective denial of service attack that way. Right, so here is kind of a diagram of that. So here the attacker is sending, well, sorry, this isn't the DNS, this is the SYN flood attack. So the SYN flood takes advantage of the TCP three-way handshake. So when you want to make a connection to a server using TCP, typically if you're accessing a website, you're using HTTP, which rides on TCP, which rides on IP. So there are layers of protocols involved. But this is taking advantage of TCP's three-way handshake. So if you want to connect to a web server, and so the first step is to send a SYN packet, or it's a synchronization request with the SYN flag set. The server will receive that and say, yes, I'm listening on that port that you sent it to, usually port 80, and it will reply with a SYN ACK acknowledging that it received the SYN and it's ready to serve up its content, and then the client will then reply back with an ACK acknowledging that it received the SYN ACK. Right, so it's a three-step process: SYN, SYN ACK, ACK, and so the web server will wait for a period of time to receive the client's ACK, or the third part of that three-way handshake. So it receives the SYN, it replies with the SYN ACK, and now it's waiting there listening for the ACK by that client. Well, in a SYN flood attack, the ACK isn't coming, so it's the attacker that's originated this request, and he is manipulating this traffic so that he never fully establishes the three-way handshake, leaving that server, it's occupying resources on that server, leaving it open for, it's not typically a very long period of time, but if you can get a botnet of systems to do this multiple times really fast, then you can overrun a server's resources. So that's a SYN flood attack. Right, and here's kind of an example of it. The attacker's computer sends the SYN, and the server replies back to a SYN ACK. So in this case, he's spoofing, other computers, or is using other computers in the attack. So web server application attacks. Right, so web servers, this is probably the most attackable surface in an organization is its web application. So everybody's got web applications, whether it's an e-commerce site, you need your users to be able to log in and access their human resources information, whatever it is. So that you need to be able to have your users connect to and receive information through the internet, usually through some kind of a web page or web portal, hosting an application. A zero-day attack is it's an attack which there are there's no patches for. So it exploits a vulnerability that is either unknown to the community or so newly known that there is not a patch. Very common it's common in things like Java, Adobe Flash, things that typically release a lot of patches. It's because a new vulnerability has been discovered. So traditional network security devices can block traditional network attacks, but they can't always block web application attacks. So if you think of a firewall, a basic firewall is going to block traffic to your user systems, right? So your user systems should not be accessible to the internet at all. Only systems that are meant to serve an application to the outside, to the internet, should allow traffic to those systems, not to internal systems that should never be accessed from the internet. So your firewall typically is what prevents traffic from reaching those systems. We'll get into DMZ and architecture later, but there are other ways you can segment so that you can ensure your systems that aren't meant to be accessed from the internet are not. But in this case, we're talking about traditional security devices. So, and the point here is that you need to have something else in place that inspects HTTP traffic, looking for known signs of attacks. So attacks like cross-site attacks and injection attacks, which you conduct these attacks through user inputs in forums on web pages. So a web server application infrastructure, right? So this is a poor infrastructure, but for the case of this, right, you've got a client out here on the internet. It talks to the web server. The web server may be servicing multiple applications. Maybe you've got your HR information. You've got an Outlook. Users can access their email, and maybe a SharePoint site. Different applications can all be running on the same web server, on the same front end. So you might hear words like presentation layer. So the web server presents the information from the application, and the application then interacts with the database where user records and the information that the client is ultimately trying to access or alter or update lies in the database. The application handles those functions, and it's presented through the web server. Right? Typically, you would have the web server in a DMZ, so that there's a firewall or some kind of access control between the web server and the application server, such that if a web server gets compromised because it is internet accessible, that it can only interact with the application server over specific ports, protocols, or in specific methods. But we're not getting into DMZ or secure architecture right here. So cross-site attacks. In a cross-site scripting attack, the threat actor takes advantage of web applications that accept user input without validating it before presenting it back to the user. So what you can do, you're going to see cross-site scripting vulnerabilities typically on things where like user forums. Not calling out anything that's vulnerable here, but if you think of sites like Reddit, where a user types in a message that they want other users to see, it's a forum with multiple potential victims, right, viewing that content. Reddit, Craigslist, AutoTrader, things like that. And what it does is, so when an attacker wants to utilize cross-site scripting, they will input, instead of a message like, hey, I want to buy this car, or this is a neat car on AutoTrader or whatever, they'll put an actual script using JavaScript. So they'll start with the script tag, the open bracket, script, close bracket, and then perform a JavaScript function, of malicious nature in that. And so when that's entered into a website, if the website is not looking to make sure that nobody's entering HTML code or JavaScript code into the user input areas, then that will go in. It will live inside of that website, and then when the next user sees that message, right, their browser will say, "Oh, that's JavaScript. I know what that is. I'm going to run that." Right, and I'll show you kind of an example of that here. Right, so here is an example forum page. So, hello class. Submit. So I've inputted user input there, a string of hello class, and it's displayed back to anybody who views this web page. But if I want to say, script. Let's see if I can remember this now. Alert. You are vulnerable. Hello back at you. I don't know, is that a period there that got put in for me? Hello back at you. So let me submit this. And here we get a pop-up now, or a JavaScript alert that says you are vulnerable. So this isn't a malicious use of cross-site scripting, but it executed code on my browser because I'm viewing it, not because I submitted it. It's because when the page refreshed after I submitted it, I was expecting the rest of that to show up here. It didn't. Anyway, the point is, because the browser loaded that content that's stored here. Let me see if I can view that. View page source, right? So comment 2, script, alert, you are vulnerable. Because this was entered in and displayed back to anybody who views that web page, the browser says, I know what a script tag is. I'm going to, oops, I didn't close it, that's why. Let me try that again. There, we entered it again. You are vulnerable twice because it's in there twice now. And there's the rest of it. Okay, so I made an error submitting it. Right, so here's the rest of it. Comment 3. There's the script. So the browser understands what that script is and performs that function alert, passing it the string you are vulnerable. Right, so that is cross-site scripting, and you can do much more malicious things than popping up a text message, basically, or a message box. All right, so they have a few slides on cross-site scripting, so let's go through them real quick. I demonstrated this. It is, right, so here's a web page that takes user input, right? Okay, so yeah, I'm not quite sure what that diagram is explaining there, but I hope that demonstration cleared it up for you. Cross-site request forgery is also a big one to be concerned about. So the cross-site request forgery is different than cross-site scripting. So instead of violating the trust that a browser has in the website that it's viewing, it violates trust that a website has in a user's browser. So what I mean there is, so there are different ways to carry this out. The idea is getting a user to make a specific web request. If a predictable user action can be tied to a specific URL request, then the attacker can craft that request and then entice the victim somehow to click on a link or visit that URL that will go to a page that he is already authenticated to, so like maybe his bank. Like the user's logged into the bank is the example in the book. And then the attacker sends him a specific URL that will say transfer funds from checking account to account XYZ of the attacker's choosing. Right? If the site can take a specific URL and perform an action, then it is potentially vulnerable to a cross-site request forgery attack. Right, and here's kind of a diagram of that. So at first the attacker forges a fund transfer request from bank A and embeds it into an email hyperlink. sends the email to the victim clicks the email, and because that victim is logged into his or her bank, the request is sent to the bank after he's already been validated, authenticated with it. He's got a session token or a cookie that maintains his state with that website, and it executes a predefined action. So in this case, it's transferring money. All right, so those were cross-site attacks. Injection attacks. So injection attacks introduce a new input to exploit a vulnerability. So the big one here is SQL injection. That's a very common vulnerability. So typically, this is something when you get out to the workplace, you're going to need to be cautious of. You need to ensure that whatever applications your developers are publishing, putting out there, and exposing to the internet that take user input, typically they're going to interact with some kind of a database. And so when that happens, you need to make sure that you are not vulnerable to these SQL injection attacks. So as we'll demonstrate here, SQL is a very strong language. So that's how somebody would interact with the databases, through SQL commands. You can list the contents of the database, you can change contents of the database, you can delete the database, you can even execute codes on the operating system that's hosting the database. So this is a very popular method of attack. Right, so the example that they give is a user forgets the password. The site that says enter your email address here, and we'll send you a email to reset your password. So that's taking user input, and if they can manipulate that input to actually do something else with the database, then they have a way to interact with that database. Now, I'll give you an example after I think we've got a few slides here. So in that example, they would select is a SQL statement field list from table where field, or in this case, it's probably that email address that they're looking for, right? Equals. Right, and so this is how the attacker would manipulate that SQL command to do something else. So where it's expecting an email address here, the attacker has entered whatever single quote, right, because that completes the text, field equals something surrounded by quotes, right, and then he introduces an or statement, or A equals A. So what do you suppose that is? So A equals A is a comparison statement. So that is asking, is this true or false? And that's true. A does equal A. So basically we're saying where one of these conditions is true, field equals whatever, or true. Well, true, right, is a true condition. So this will do something unexpected. In this case, it will return all email addresses. Right, and there's kind of a form that may be vulnerable. It's hard to tell by looking at the form, but I guess that's what a vulnerable form looks like. And then here are some example of malicious SQL injection statements. So the attacker would enter whatever. Notice how there's not an opening quote. That's built into the application. The application is taking this whatever is meant to be entered in here, right? That should be an email address. Right, then the application will put its own quote at the end of that. But if you put your quote there instead of the application, so you put the quote inside of your user input and then fill on with additional SQL commands. So and email is null. right? And so the semicolon is a SQL end of statement line, and then this dash dash indicates that everything that follows is a comment. So that comments out the rest of whatever the application intended to, if they had additional SQL commands past your input. It just comments it out. So email is null. Not sure what they're trying to do there. So the result is determine the name of different fields in the database. Okay, so there are different ways you can try to figure out what all is in that database. Right, and 1 equals select count star from tab name. So star is a SQL wildcard character for everything. So select everything from tab name. So then the idea there is to discover the name of the table. Or full name like Mia. Like is a SQL command that will try to match on similar. It's kind of like a search. Whatever, let's see, so drop table, right? You can kind of imagine what that's going to do. Drop table is going to drop the rest of, is going to destroy the table. Update members, set email to the attacker's email address, where email equals mia@good.com, right? So that would be a way to change the email address of a user, and then you can go to the password recovery page and say reset my account, reset my password, and then you'd be able to then log in as Mia. Right, so let me give you a demonstration of that. So here I'm using a vulnerability, so the distribution of this virtual machine is damn vulnerable Linux. It has all kinds of neat vulnerable applications to play around with. I highly recommend it, and you will probably get more into this if you go down the ethical hacking path in your degree program. So here is a login page, right? So let me get my notes up so I get this right. All right, so what we're doing is we're logging in as an employee, right? We don't know the password. I'll just guess a password here, hit log in. That's no good. Login failed. Restart this. There's a second bit to this that's not really relevant. Inside of the page is some code that limits the input of this field. I'm just disabling that. Firefox offers some good developer tools. So remove maximum length just changes the HTML of the page I'm looking at that established that maximum length. So now I can go past 8 characters, which I'll need to do to give it my SQL commands. Right, so here's what we're going to pass it. So, right, this is what it's expecting for the password, and I'm giving it a single quote to end that string that it's expecting, and then I'm doing an OR statement, or 1 equals 1. Right, and I'm not filling in the second quote because I know that lives. That's the next, right? That's predefined in the back end. I don't need a quote there, so copy that. We'll paste it right in. So it's stuff semicolon or 1 equals 1. Let's see if that works. Right, and there we go. Now we're logged in. So that's just one example of a SQL injection attack. So now I've logged in without knowing the password of somebody. No, if I did the restart this lesson, disable that, the form maximum length again, log in as the individual Neville. Neville is the boss, so you can kind of see a little more content here. Paste that in again and log in. Now we've logged in as the boss. We can go in and view profiles of all the employees, right? Delete profiles, create new profiles, all kinds of fun stuff. So without knowing the password, I was able to execute a SQL injection to gain access to, looks like, employee information. All right, so that's SQL injection, or injection attacks in general. Next, we've got hijacking. So hijacking, there are several attacks that result in threat actors commandeering a technology and then using it for an attack. So hijacking is kind of what it sounds like. If you think of somebody hijacking a train, they've taken control of the train and now are steering the train. So you've got session hijacking, URL hijacking, domain hijacking, and clickjacking. Session hijacking is where an attacker is attempting to impersonate a user by stealing or guessing the session token. So a session token is what will, so if you think of a web page, HTTP, when you request google.com, you are just making a GET request, get this page, right? So after you've logged, let's use your bank as an example. If you want to log into your bank, right, you put in your username, your password, you hit login, the application on that back end says, this is an authenticated user, then it will send a session cookie, or send a cookie and a session token. The session token is usually within that cookie. It doesn't have to be, but anyway, you've got a session token now. And now the next request, like view my accounts, click the button that says, what are my accounts? When you click that, your browser is sending that session token along saying, hey, I'm already authenticated. This is my session. It's an active session. It's okay to view the account of whatever user you've already authenticated as. So session hijacking is being able to use that session token, not as somebody else. The attacker uses the victim's session token to interact with that web server as the victim. So that can be done a couple of ways by stealing it, right? If you have a way to take that off of the victim's computer in some way, you've got malware running that can let you interact with it and search for that. Otherwise, a browser attack can monitor for cookies and then upload them to the attacker, things like that. Or if it's a guessable session token, so vulnerable web servers may have guessable, predictable session tokens. It's kind of hard to get into, but if they're not completely random, then the possibility is there for the attacker to figure out what that session token is going to be, and they can try thousands of sessions at a time until one of them works. So they really just have to get close. But if it's not completely random, then session guessing or brute forcing session keys, session tokens, is a way to conduct session hijacking. So URL hijacking or typo squatting. If you go to google.com and you drop the second O, and you went to goggle.com, right? So if an attacker registered that domain goggle.com and hosted his own content there, maybe he made it look like google.com, except he has ads going in the background that maybe you don't realize you're not in Google. Right, so that's the idea, is registering domains that may be inadvertently typed into the browser. And bit squatting. Now, I hadn't heard of this before. Still seems a bit off to me, but it's in here, so let's learn it. Flipping one bit in the domain name, in this case the bit that changes it from a G to an F, right? Making it Fugle.com. Not really sure where you who that's victimizing, but it's in your text. Read up on it. Domain hijacking. Let's talk about that. No, URL hijacking. So domain hijacking occurs when a domain pointer that links to a domain name links a domain name to a specific web server is changed by the threat actor. All right, so you may go to so let's use Sentry as an example. I don't know firsthand, but I believe there are multiple web applications that are hosted on probably the same front end, like our diagram before. There is, if it's running Apache, it's in the configuration to say www.sentry.com is this application, or D2L is this application, and so on and so forth. So if you can change that configuration and redirect people somewhere else, then that would be domain hijacking. Would be one case of it. So another case would be actually changing the records in DNS or the domain control panel to redirect requests to that domain to a different physical server, to change the IP address from the web server that should be displaying the content to the attacker's web server, similar to DNS poisoning. Clickjacking. So a hijacking a mouse click. So the user is tricked into clicking a link that is other than what it appears to be. So this is done when an attacker uses multiple transparent layers on a web page to trick a user into clicking on a button or a link on another page. So if they're displaying content and they want you to click on something on that page, they can through HTML or through iframes, they can put something else over top of that may not be visible to the human eye, or the hover over method. So that's just using embedded iframes in HTML to take you somewhere you didn't plan to go when you click in a specific area on the web page. Overflow attacks. So buffer overflow is the big one here. We'll also talk about integer overflow. So the buffer overflow occurs when a process attempts to store data in RAM that is beyond the boundaries of what it is expecting, of what it's expecting that input to be. So just like in web attacks, you prevent overflow attacks with input validation. So if an attacker can overflow the buffer with a new address that points to the attacker's malicious code. So what they'll do typically is they'll use no-op sleds. They'll put in a specific character that the processor knows that this isn't an operation. Just skip over this bit, skip, and if the attacker just inputs a bunch of no-op sleds, no-op bytes in there, they call that a no-op sled. Then the pointer will stumble on that and go all the way down, and then at the end of that sled they would put their malicious code. So if they know that the pointer is going to access anywhere in that no operation sled that they've input, just massive nops or no ops, then they can have the processor execute their malicious code. Right, so the normal process here, the program instructions, buffer storing integer data, buffer storing character data, and the return address pointer. So the return address pointer goes back to the instructions. The overflow attack takes advantage of that jump and goes into the buffer storing character that they have overflowed. Right, here's the boundary, it's overflowed it, and then they'll put the malicious code or a pointer to malicious code at the end of that buffer. So the integer overflow, it's a condition that occurs when the result of an arithmetic operation exceeds the maximum size of the integer type used to store it. Right, so integers are only allowed a certain size. So the attacker changes the value of a variable to something outside of that range that the programmer had intended to be used by the integer. Right, so if they do that in some instances, a very large positive number can become a negative number. So if you could imagine a situation where maybe you're transferring a very large number into somebody's bank account, but if the program can't process that very large integer and instead reverses it and makes it a negative number, then you can reverse the flow of the money. Right, and so advertising attacks. So we'll talk about malvertising and ad fraud. So malvertising is basically, so it's advertising. So, you know, when you visit a web page, you've got ads on the side of it. They pop up and, you know, entice you to click on them. So malvertising is a way to poison an ad attack. So to put malicious code in there instead of an ad or a link to malicious code. Right, so malvertising is a big problem. It's very difficult to prevent. It's difficult to respond to as well. So preventing it is difficult because they'll typically go through one of any number of advertising online marketing companies that have pre-negotiated contracts with different vendors. Typically, when you have a website that you're hosting and it has ads and you're using one of these marketing sites, you've got very little insight or input into what kind of advertisements get displayed there. That's up to the marketing people who should have different algorithms to, you know, they're tracking users' cookies. And so, right, if a user has shopped for a Ferrari, right, or viewed, you know, done Google searches about a Ferrari. So the marketing ad will look at those cookies and say, okay, this person's interested in a Ferrari. So when they go to another web page, they'll see an advertisement that says, hey, you know, come visit your local Ferrari dealer. But if instead an attacker is able to upload an advertisement, just like any other business would, get an advertisement into the pool that takes them to a malicious website. And so yeah, so that's malvertising. All right, ad fraud is threat actors manipulate pre-roll ads. So a pre-roll ad is if you go to YouTube and you don't pay the subscription or whatever, you have to watch advertisements before your video every so often. So what happens there is that there is kind of an auction that happens in milliseconds of which advertisement you're going to see. Different advertisers will bid. I'm not really sure what the variables there are or how they, you know, how they determine how much to pay for an advertisement. But they will pay YouTube or whatever site you're on to show their advertisement, and that kind of happens in real time as you click go in the video. So attackers have found a way to replicate that activity to make it look like a user is visiting YouTube or whatever site, and you know it prompts that pre-roll process where different people different companies are bidding on which advertisement to play for that. So they've automated the user activity in this software they're calling MethBot. Right, so it interacts, it initiates, it carries out, and completes everything needed for the ad auction to complete, and so they're able to make money off of this is the goal there. So web browser vulnerabilities. Web browsers highly vulnerable, or it can be, and a lot of this has to do with things that the user installs. So you've got browser extensions, browser plugins, and browser add-ons. Right, and so typically this is scripting code. So we talked about JavaScript earlier when we talked cross-site scripting. So JavaScript is the most popular scripting code for web pages. It adds a lot of functionality to it, and it makes our modern web pages very interactive, very dynamic. It's all the rage. If you get into web programming, you'll learn JavaScript. But there are security concerns with that. So JavaScript can be used maliciously, can do things like capture, remotely transmit user information without that user's knowledge. Right, and so that script can be implemented in the browser through extensions. So browser extensions, they expand on the normal capabilities of a browser. So if you think of Flash, usually you'll have, I guess that's a plugin, isn't it? So you've got browser extensions that extend the capabilities of the browser. Right, plugins add new functionality to a browser, so it can play music, view videos, display special graphics, and that would be like an Adobe Flash would be an example of a plugin. Right, so a single plugin can be used on different web browsers. Flash is, it'll work on all the web browsers. A common plugin supports Java. Right, so you've got Java, Flash, QuickTime, Adobe Acrobat Reader, things like that. Right, and there's their little animation. So you've got the HTML document. There's the typical HTML. You've got the Java applet. The browser will take both inputs and display your website plus whatever that Java applet does. So it runs the Java applet. Right, so some things add-ons can do. They can create additional browser toolbars, change menus. They can be aware of other tabs open in the same browser. Process the content of every web page that's loaded. Right, so to reduce these risks, a lot of companies now, so HTML5 isn't new. It's relatively new, but it's not brand new. And companies are just now starting to transfer their dynamic content from things like Flash plugins into HTML5, which supports video and other dynamic content by just natively. Right, and so here's kind of a description differentiation between the three. The extension is written in JavaScript and has a wider access to privileges. A plugin links to external programs, and an add-on adds functionality to the browser itself. And some of these, okay, so a summary. So we've got attacks. Some of the attacks are designed to intercept network communications, man-in-the-middle replay attacks. We talked about different kinds of attacks. You had the poison, right? So ARP poisoning, DNS poisoning. We talked about DNS amplification, SYN flood attacks. Remember the Smurf attack. Cross-site scripting, cross-site request forgery, SQL injection. Right. So, all right. Well, that's the content I had for you. So ensure that you are completing by Wednesday. You've got your lab simulation complete, the virtual lab. You've read, make sure to read the content. Don't just rely on lecture. Make sure you read and understand the book, and then take the quiz. All right, well, that's what I have for you this week. Have a good week off. Again, a reminder that next week I will be traveling for work, and so I will either do another one of these videos, or what I hope to do is do an online class. So I've yet to figure that out. I will either figure that out or record a video for you, and I'll let you know in advance so you're not surprised either way. But I'll see you next week. All right, take care.